Hello, in this video we're going to take a look at the concept of similar triangles. Similar triangles are triangles that have the same shape and therefore the same angles. They do not have to be the same size. So we can see that triangle ABC and triangle DEF, they have the same angle measurements, 100 degrees, 50 degrees, and 30 degrees. But they have different side length measurements. However, they look the same. So they're similar in that they have the same angles. And so when we want to show similarity, we can use a wavy line. Triangle ABC is similar to triangle DEF. How can we determine if triangles are similar? We can determine by a ratio of the sides. So if we want to make ratios, we can see similarity by, let's say, taking line AB, which is 6 centimeters, and placing that over line DE, which is 4.5 centimeters. And then we can check this to see if the other sides will have the same ratio. And so we can go ahead and put BC, which is 8, over EF, which is 6, and then we can take the hypotenuse here, the longest side is 10, that's AC, and DF is 7.5. And if you take your calculator and you take 6 divided by 4.5, you get a decimal of 1.3 repeater. And if you take 8 divided by 6, you get the exact same decimal. And 10 divided by 7.5, again, you get 1.3 repeater. And so when the ratios work out to equal the same, then you know that the triangles are similar. So when we know that triangles are similar, we can use this knowledge of ratios to solve unknown sides. We can see that this angle on the top corresponds with this angle, and that they both have a right angle, 90 degrees, and that the angle on the bottom, these are the same. So we know the triangles are similar through the way their angles are displayed to us. Now we can set up and solve for unknowns. We can solve for y or for x first, it doesn't matter. So we're going to create our ratios. So I'm going to take the sides that I know, 3 and 7.2. I'm going to put those over each other, and it doesn't matter the order that you do this. What matters is consistency. So I'm going to do my small triangle's length over my larger triangle length, and then I will do the same thing for the 4 and the y. So I will write an equal sign. I will use my small triangle length over the larger triangle length, and now I can use either algebra or my shortcut method. I can cross multiply 7.2 times 4 and divide by 3 to solve for y. So I take my 7.2 on my calculator, multiply that by 4, that's 28.8. I divide by 3, y is equal to 9.6. I can also solve for x. Again, I can use the sides that I know. 3 over 7.2 is equal to, and then again I take my small one, 5 over x, and I can solve for x. And I can use that method, cross multiply and divide. That's my fastest method, although I can cross multiply both directions and then isolate x. So 7.2 times 5 divided by 3 equals 12. X is equal to 12. Sometimes you have a word problem, and when you have this, you should really try to draw what you're reading about. It slows you down and helps you to see what you need to do. So here we have a person who stands 180 centimeters tall. They cast a shadow that's 45 centimeters long. A nearby telephone pole casts a shadow 300 centimeters long at the same time of day. What is the height of the pole in meters? Okay, well, I'm going to start to draw. So we have a person who is 180 centimeters tall. So I can label that here. And they cast a shadow. So the shadow is going to be cast from that person. And the shadow is 45 centimeters long. Now we have a telephone pole which casts a shadow that is 300 centimeters long. What is the height of the pole? So we don't know how tall the pole is, but we do know how tall the person is. And so because we're drawing basically similar triangles, we can now set up ratios. So I know the person is 180 centimeters tall, but I don't know the height of the pole. So I'm again using my small over my big. And then I'm going to take the values I know. 45 is my small. Over 300 is my large. And now I can solve for x. This time I'm going to cross multiply 300 times 180 and then divide by 45. So I take that on my calculator and I'm getting a height of 1,200 centimeters. And that makes sense if we look at the relationship between the height of the person. Person was 180, shadow was only 45. Height of the pole, 1,200, shadow is only 300. That seems to make sense. We can check this by taking 180 over 45 is equal to 1,200 over 300. So we could check this way and we can see if our decimal works out. So 180 divided by 45 is 4. And 1,200 divided by 300 is 4. So we have balance there. We know that these are similar triangles. Even though one is small and one is big, the relationship between the numbers is the same. Sometimes you'll face a question where the orientation of the triangles is kind of flipped around, and these ones can be quite challenging because we need to determine the length of x, but the triangles are not oriented similarly. What I do here is I do a redraw and I line up angles. So I'm going to show you how I do this. So I'm going to take the small triangle just the way it is, and I'm going to label everything. B, A, C, and the dot up above is the first angle, and then right here is the right angle in the corner. And so the length of BC is 5, and the length we don't know of AC is x. Now I'm going to draw the big triangle the exact same way, and I'm going to look at the angles and I'm going to label. The dot will go up in the same position as the small triangle, and the dot side is E. The right angle will go in the same way as the small triangle, and the right angle is labeled D. C is in the same position as the small triangle, and the length between C and D is 11, and the length between E and C is 15. So I basically flipped that big triangle around, lining up that I have my dots lining up in the same corner and my right angles lining up in the same corner, and that way I can be absolutely sure where my numbers are going to go. Now that I have that, I'm going to put my small triangles over my big. So I'm going to take the side I know, the 5. I'm going to put that over the same side on the big one, 15, is equal to x from the small one, over top of its same side on the big, which is 11. And now I go ahead and cross multiply and divide. So I'm going to have 11 times 5 divided by 15. And I will get a decimal here, and you don't need to worry about getting a decimal because the question is saying round your answers to the nearest tenth if necessary. So we can be prepared for a decimal. It's 3.66. So we are going to round this up to 3.7 for our x length. This last one we're going to do slightly differently. If we see that we have the inside triangle with a length of 10 and 16, this is EB, and this is F over here, and then we're trying to find the larger triangle where we have a Y here and the 10 and a length of 24, we can see that this is going to be Y plus 10 is the full length of the larger triangle, and 24 is provided to us. So we can set this up as a ratio. I'm going to put 10 on the smaller triangle over Y plus 10 is equal to 16 on the small triangle over 24. For this one, we can't really use the cross multiply and divide shortcut so well, so I'm going to show it a little differently. We're going to simply cross multiply, and we're going to solve algebraically. On one side, we're going to have 10 times 24. On the other side, we're going to have 16 multiplied, and I'll use brackets, to y plus 10. So we will need to distribute on the right-hand side. 10 times 24 is 240 on the left, and then let's distribute. 16 times y is 16y. 16 times 10 is 160. And now we can solve this two-step equation. We're going to subtract 160 from both sides, and that's going to give us 80 is equal to 16y. And now we can divide by 16 in order to isolate the variable. And 80 divided by 16 is 5. So y is equal to 5. So now we have it. Y is equal to 5. And so this whole length is actually 15. And we can again do a check if we wanted to make sure that this works out. So this whole side, 5 plus 10 is 15. Over the smaller triangle is 10. Is equal to the whole long side is 24. Over the shorter side is 16. And we can find our answer in a couple of ways. We can divide them and get the same decimal, or we could cross multiply and see if we get the same answer. So I'm going to take 15 divided by 10, which is 1.5. And 24 divided by 16 is also 1.5. So I know that I have the right solution for y. As you try the exercises, I'll give you a few strategies. Firstly, when you create your ratios, be consistent. Small over big or big over small, it doesn't matter. What's important is that you maintain consistency. So if I'm starting with my small triangle and I'm doing 5 over 7, then I can make x over 9. So just be consistent in setting up your ratios. Draw pictures for word problems. and redraw triangles to face the same direction.